Welcome back to the sixth video of this series. I'm Aaron Angel, owner of Nightingale LED Solutions and co-owner of the LED Costume Academy. I have over 10 years experience in wearable technology and soldering on the Las Vegas Strip. Hopefully, you've watched the other videos of the series, and don't forget to hit that like button and subscribe for upcoming videos. And please feel free to comment to help others learn. Today, we will be looking at some LEDs and then through-hole soldering. There are many LED types to choose from, including indicators that almost everyone has seen, as well as the SMD on LED strips. There's also many variations of COB or chip-on-board LEDs. These may or may not come mounted, but due to the high heat requirement, require some form of heatsink to dissipate the heat output. For this lesson, we will be focusing on indicator LEDs. These are common 2-pin, but can also be in color mixing applications, such as this RGB, or flat panel mount and require more pins. Be sure to consult the manufacturer and documentation to find which pins are positive, anode, or negative, cathode, as well as the voltage and milliamp rating of your particular LED. The negative should have a flat side and have a shorter lead. The LED will light up when the power travels from the anode to the cathode, but will not light up if the power runs from the cathode to the anode. To help which is positive and negative, remember the acronym ACID, anode current in diode. On a standard through-hole LED, one of the leads will be longer to help you know how to wire your LED. Convention is a longer pin is the anode, but there are exceptions, so again, consult your data sheets. However, if you look inside a clear lens LED, you'll see the cathode or negative is connected to the larger plate, or anvil, and the anode, or positive, the smaller plate, or post. There's an epoxy lens, reflective cavity that holds semiconductor die, and a very tiny wire bond. Bi-pin through-hole LEDs come in different sizes. The usual size ranging from 2mm to 7mm. Shapes in dome, flat, triangular, convex, or concave, dictating their beam spread, and covering from 2.5 degrees up to 200 degrees of spread. And every color, with every Kelvin temperature of white, including LEDs outside the visible spectrum, including UV and infrared. LEDs and most components are sensitive to high temperatures. When soldering, you want to keep this in mind and use the proper temperature for your solder type and tip size. We'll be looking at through-hole soldering, which is what you'll be soldering if you do any clean with alcohol on both sides. And wipe off any residue with a chem wipe. Tin your tip, and depending on the hole size, you may want to pre-tin the pads. Use a solder wick to remove any excess solder to expose the holes. You'll want to bend the leads with the pliers to 90 degrees to match the holes if they don't originally line up. There are jigs available with variable sizes. Place the leads through the holes. and then gently bend to hold the component in place. You'll want to use a flush cutter to trim excess lead wire so that heating the element doesn't interfere with anything else on the PCB. You'll apply flux to both sides of the board, but solder only on the underside of the board. Heat the piece and apply solder to one side. Then slide the iron over to create a solder bridge. And repeat on the second lead of the component. Clean and inspect your joint. And trim off any remaining wire. You want to make sure that you have full coverage of the pad and the pin is fully wetted, and also to avoid too much or too little solder, overheating the joint, or creating a solder bridge to another terminal. Also creating a solder ball on the terminal post that doesn't adhere to the PCB copper, which is caused by not heating both the post and copper evenly. Using flux on a wider tip point will help this. Other things to look for are one-sided, pad not fully covered, not touching the pad, and pin not well wetted. Hopefully you've started to understand the process of through-hole soldering, and please join me in my next video on crimping terminals.